Okay, now I'm recording. Good. So this explanation is about 6.2. This is representation of functions. Okay, and we can state here that there are three ways in which we can represent functions. Okay, and one of them is by a word description. Okay, well, maybe I said three. Let's say there are several ways in which we can represent a function. Word description, let's say, I don't know, let's use Miguel. Miguel is a student. Miguel scored 140 points in math in 2017. Then 160 in 2018. And then imagine I keep writing here a description of his grades. Okay, this is a way to represent a function. Then I can make a table. Okay, I can make a table and I can say, okay, if I take on this side x, which is going to be time, years, in which year I'm talking about, and y is going to be the grade. So I'm going to say, okay, when he was like in 2017, he scored 140. Then in 2018, he scored 160. Then in 19, he scored 155. Then in 2020, he scored 160 again. Okay, and I can keep writing data in this table according to the word description. Then I can also express this as a graph. Okay, I can graph this. So let's do it here. You know that always I'm using the horizontal axis for x, in this case is the year, and y is the vertical axis. Okay, as my values for y begin at 140, I'm not going to, I'm going to do this. I want to make this thing, it's like a lightning. Okay? If I do that, it means that I'm skipping some values. Okay, so here I'm going to write 140, 145, 150, 155, 160, 165, and so on. Okay, and here years, 2017, 2018, 2019, 2020, and so on. And then I can plot the values from this table, which are actually are points, right? I have the point 2017, 140. That point is placed here. Then 160 here. Then 155. Then 160 again. Okay. And I can join the dots and I can make a graph. Okay. And imagine I keep obtaining values here, okay, for this student. Good. So I get a function here, right? And I express this function in three ways. Okay, I express it with a word description, with a table, and then with a graph. And if you remember from yesterday, this is a function. We can state it's a function because it passes the vertical line test. I only have one value of y for each value of x. And it's very clear to see this in this case because we are speaking about grades at a specific point in time. I cannot score two different grades in 2017. My grade is one, okay? That's why here for each value of x, I can have one and only one value of y. If I have two, it doesn't make sense. okay? And this is why we say that a function is a relationship between two variables, in this case, x and y, but this is not an equal relationship. Like it's not a relationship which goes in both directions. No. In this relationship or in this relation, there is an independent variable, which is the x. This is the independent variable, and this is the dependent variable. Okay, so there are two different rows. Like each variable is in a different row. Okay, that's why I can have one and only one value of y for each value of x, but I can have two values of x for one value of y. I can have the same grade in 2 different years. That's perfectly possible, okay? But that's because here the x is the independent variable. The years are going by regardless of anything, but my grades depend on the year, okay? So that's it. And these are the three ways in which I can express a function. But there's another way to express a function when it is predictable, okay? So some functions are predictable. And I have many types of predictable functions. I have linear functions, which are the ones that can be represented with a line. I have quadratic functions, which have the shape of a U. There are many exponential functions. You will learn about this in coming years. This year, we are focusing on the linear functions, okay? So specifically among the predictable functions, we can talk about linear functions, okay? And linear functions, we can express them also as an analytical expression. I will say what that is. Okay, so let's start by the word description. And let's use an example from the previous bimester. Let's say, okay, Luciano read 5 books so far, and he'll be reading 2 more per week. Okay, that's a word description. I can express this as a table. Okay, on week 0, that's at this moment, he has read 5 books. Then 1 week afterwards, he has read 7 books. 2 weeks afterwards, 9 books. 3 weeks afterwards, 11 books, and so on. Okay, and here this is predictable, right? I can predict what's coming next. Okay, so I'm going to graph this x and y, and here I can say that at 0 I have the point 0, 5, 0, 5, I have the point 1, 7, I have the point 2, 9, 3, 11, okay? And then, as this is predictable, and this is a linear function, it has this shape. It's a line, it's a straight line. And when it's predictable, as I said, in the case of linear functions, there's another way to express this, and is by using an analytical expression. Okay, and this is why we will learn in next week uh, how to infer, how to write this equation, even though you know that from previous bimesters, but here in this case, this is going to be 5 plus 2x, okay? And I can express this also as 5 as f of x, okay? Y and f of x is the same. F of x means function of x. So in this case, as it's predictable, it's a linear function, I can say, I can express it in four ways. Verbal description or word description, table, graph, and analytical expression, okay? And you can prove this because if I replace values here, if I say, if x equals 0, what's the value of y? Okay, if x is 0, y is 5 plus 0, 5. Okay, it's true. If x is 1, 5 plus 2, 7. It's true. So this analytical expression corresponds to this table and corresponds to this. Okay, so I'm going to stop recording here.